Okay, so this is trigonometry. You guys are doing your 3.4 linear and angular speed. Linear is your distance over time. Angular is your angle over time. So here, try this. All right. All right, so linear speed. Linear speed is going to be the distance over time. The distance is going to be this S over time. Okay, how fast is going there? Distance over time. Distance is the S value. Time is the T value. Speed is my V. Okay, there's a couple of variables. We're going to be using those a lot.
Suddenly this became physics.
It is. But it's so much easier than physics.
It is easier.
This is easier. Trust me, you'll get this. All right, to go along with this, we're going to have angular speed also. It's the angle over time. It's the change in the angle over the time. And the variable I use for this is going to be W. Angular speed is my W. Okay, angular speed is the W. So now this next one, there's a whole bunch of different formulas I'm going to use. These are going to be very, very helpful. So angular speed is going to be W. Linear speed is V. So linear speed, we could solve it using different methods. Okay, different ways. Just depends on the variables that are given to you. Angular speed, you can only solve it one way. So you have to have theta and you have to have time. You have to have your angle and you have to have your time. You have to have that. Okay, and theta has to be in radians. All right, so suppose point P is on a circle with a radius 10 centimeters. 10 centimeters. And ray OP is rotating with an angular speed. Ooh, angular speed. Angular speed is what? What variable?
V.
W. It's W, right? Angular speed is W. Let's look. Angular speed is W, right?
Yeah.
So I know that W is what?
Theta over T.
Pi over
18.
pi over 18. Very good. Pi over 18, right? Pi over 18, and that's rads per second. Okay, what other variable did I get?
10 centimeters.
I got R is 10 centimeters.
Yeah.
Okay. Find the angle generated by P in 6 seconds. Okay. What other variable do I have now? I have 6. What is 6? Seconds. So what variable is that?
V.
T.
T.
T, time.
Time. Yeah.
Time. So T is 6 seconds. Very good. T is equal to 6 seconds. Okay, so now find the angle. So angle is what variable?
W.
That's angular
I
speed.
mean, no.
S.
Let's go back.
V.
Find the angle.
Theta.
Theta. So it's either going to be this one here or this one here. So I'm going to use one of those two variables or one of those two formulas to find for the angle theta, right?
Yeah.
Because I'm looking for theta. I need theta. So these are the only two that have theta, right?
Yeah.
Now let's look carefully. Do I know what R is?
Yeah.
No. Yeah. Yeah. Yes, you do.
Yes, I do. What was R?
10.
Do I know what T is?
Yeah. 6.
Yes.
Do I know what V is?
Pi over 18.
No.
No, you don't.
V. I didn't know
No,
V.
you don't know V.
I don't know V. Okay.
You don't.
So listen. Now watch this. If I don't know two variables, I can't use it.
You're right.
Now let's go over to this one. Do I know what T is?
Yeah.
Do I know what W is? Can I solve for theta now?
Yeah.
So theta is the only unknown, so I can solve for that. So W equals theta over time. So W is equal to theta over time. So W is pi over 18 equals theta, which I'm looking for, over time, which is
6.
6. Very good. Now, since I'm trying to get theta by itself, what am I going to do here? Multiply by? Yeah, multiply by 6, right? Because I'm trying to cancel out that 6 on the bottom.
Yeah, the cross multiply.
There we go, right?
There you go.
So, now this is going to give me 6 pi over 18 is equal to theta. But can I reduce this 6 over 18? Yes, by how much?
By how much did you use?
2.
I could do more than 2. I could do 6, right?
Yeah.
6.
I could reduce it by 6, right?
Oh, yeah, you can. Yeah.
And so what's that going to give me?
1 over 2. Pi over 2.
Pi over
I think it's solve it.
3.
Yeah.
Pi over 3.
Oh, 8 times. Yeah.
Pi over 3 is equal to my theta.
There you go.
Because I could reduce that by a factor of 6. 6 divided by 6 is 1. 18 divided by 6 is 3. That's where I get that from. All right, we solved it.
That's it.
It's not bad, right?
No.
I just need to list everything I have. I think I calculated it last one. I think there's 6 different variables that we're going to be dealing with here. We just need to know and understand which ones we have and which ones we're looking for. All right, let's take a look at this next one. So from my previous one, it's the same stuff. And it says find the distance traveled. Okay. So that means distance traveled. What is the distance? What variable represents distance?
W.
No,
The
no.
S.
No,
The
that's-
theta.
I heard it.
The S.
The S. Distance is the S. Distance is the S. Very good. Okay, so if you didn't know that right now, so you need to actually notate that. So distance is the S. Okay, distance is the S. You want to write that on your notes, right? Okay, find the distance. So right here I'm looking for S equals. Okay, in 6 seconds. So T is 6 seconds. What else? We know that W was what? Pi over 18, right?
Yeah.
R is 10,
Oh.
right?
Yeah. You're right.
Okay, what else did I find? Did I find theta?
Yes.
Yes.
What was my theta?
Pi. Theta. It was pi over 3.
Pi over 3. Okay. So I have all those things, right?
Yeah.
So I'm listing them out to help me out. And now I'm going to go back to my formulas and look at where can I use S? So I'm going to clear this up. So which one has S?
First.
Oh, it's only this one, right?
Yeah.
It's only this one. So that's the only one I could use. So I need to have, to solve for S, I need to have T. Do I have T?
Yeah.
Do I have V? We don't have V, do we?
No.
Okay. Can we solve for V?
Yes.
We can solve for V. Do we have R?
Sure.
We have
Yeah,
R.
yeah, yeah.
Do we have W?
Yes.
We have R and W. So we can solve for V, can't we?
Yes.
All right, that's good. That's good. So before I solve that one, that means we're looking for linear speed on this next one. So that's V, right?
Yeah.
So V equals RW. So V equals, what is my R?
10 centimeters.
10 centimeters, right?
Yeah.
Times W, which was?
Pi over 18.
Pi over 18.
Very good. Pi over 18. So now can we reduce the fractions here? So V is going to be equal to how much? 5 pi over 9. And what is the distance over time here? What's the distance? What are my units of distance? Centimeters per. Very good. Centimeters per second, right?
Yeah.
So now, we have V now, don't we?
Yeah.
So I know I'm looking for S. So back in that formula sheet, right?
Yeah.
I know that V equals S over T. So V was 5 pi over 9 equals S over T, and my T is 6. 6 seconds. All right, so now from here, what am I going to do to get my S by itself? Multiply by 6.
And you cancel out.
So now, can I do any reducing over here also?
You can.
Yes, I can.
Yes, you can.
So I'm going to get what?
You solve.
Hmm?
So 5 on top.
Yeah, that's 5.
By 5. Divide by 5.
Are you saying
Yeah.
this? That's an S. That's my variable S. I'm trying to over exaggerate my S so I don't think it's a 5. So what'd you come up with?
10.4.
No, no decimal.
But that's a 10. No. No.
Okay, so now, is this a whole number here?
No.
Yes.
Yes, it is.
So I multiply the top, right?
Yeah.
So that's going to give me
35.
30
5.
pi over 9. Can I reduce 30 pi over 9?
Yes,
Yes.
you can.
By how much?
3.
By 3, right? So by 3, so that's going to reduce to 10 pi over 3. So we were able to do this one, but I had to go find something else first. Sometimes you will have problems like that where you have to solve for another variable first before I could do this. Questions?
So you just divide that and you get down to 10 over 3.
Yeah. I just reduced it. 30 over 9 reduced by a factor of 3.
That's easy. I get it.
Okay?
Mhm.
All right, let's take a look at the next one. Now, a belt runs a pulley the radius of 6 centimeters at 80 revolutions per minute. Now, we did this a long time ago. What is 1 revolution?
Oh, 260?
Huh?
Oh,
260?
360, isn't it?
Yeah.
But now, we're not working in degrees, we're working in radians. So what is a whole circle in radians?
180? 90?
No?
2 pi.
2 pi, very good.
2 pi? Oh.
It is 2 pi. A whole circle in radians is 2 pi, right? So we know that 1 revolution is equal to 2 pi. So since this is not on your units or on your notes, maybe this is something that you could add there that would be helpful. Hint, hint, write that down. So 1 revolution is 2 pi. But it's revolutions per minute. Right? Revolutions per minute. So I'm going to set this up as a changing change a unit. So we're going to change it. So it's going to be 80 revolutions for 1 minute. Okay? We're going to change the units on this one, all right? So I have revolutions on top. So I'm going to multiply this. So where does revolutions got to go? On the bottom. So revolutions here.
Minutes on top.
Okay, but a revolution is 2 pi. What is pi though? What is 2 pi? What units am I using there?
Degrees.
Degree.
Not degrees, radians. So those are rad,
It's a
right? So now let's go ahead and put these in, right?
It'll be
1 revolution is 2 pi radian, right?
Yeah.
Now this next one, it says find the angular speed of the pulley in radians per second. Radians per second. So what's the problem here now?
It's in the
It's in minutes, right? I need to convert that. I need to convert that to minutes now. Or, I'm sorry, seconds. So I'm going to multiply again. So what's going to go on top?
Seconds.
Rad.
Nope.
Oh, review. I mean,
No, oh, revolution.
minutes.
Why minutes on top?
Because it's by itself.
Minutes are on the bottom here, so minutes go here. And then on the bottom, I put my seconds, right?
Yeah.
So I get, what number goes on top? 1 minute is 60 seconds. Okay, let's do some canceling here. So revolutions go away, minutes go away. So on top, I'm going to come up with what?
2 pi.
2 pi.
Multiply.
160.
So it's 160 pi
Over
rad over how much?
60 seconds.
60 seconds. So,
160 pi radian over 60 seconds. Can I reduce that now?
yeah.
I can. I could reduce that. Go ahead, reduce those, please.
What do you call?
No.
Did not?
Do the fraction. Don't put it in the pi. Just do the fraction. It's 160 over 60.
10 over 6.
10 over
No, isn't it 8 over 3?
8 over 3. It is 8 over 3. So this is going to give me 8 pi over 3 rad per second. Now, we're finding angular speed, and it's angle over time. There it is. Angular speed is radians per unit of time. Radians per unit of time, right?
Yeah.
So do I have radians per unit of time here?
No, yeah, radians per seconds.
What's the unit of time?
Oh, it is seconds.
That's time, right?
Yeah, you're right.
So is this going to be my yeah, there it is. There's my W, right?
Yeah.
My W, that's my angular speed there.
Yeah.
Make sense? Is this hard?
No.
The hardest thing is actually identifying and keeping track of all your variables. Okay? So I want you guys to get started with this. Okay, we'll finish it on Thursday.